Guidelines for sketching a curve. We're going to kind of put together what we've learned about derivatives that help us know the shape of the graph and what we already know about sketching curves from college algebra. Let's look at the graph of this function. And if we asked graphing technology to graph that and we had a look at this graph, it looks like it's probably always increasing with maybe a saddle point right here. However, if we got in a little closer, we would see that no, this graph is increasing, then we have a place where it's decreasing, and then it turns and it's increasing again. So just using graphing technology can sometimes be a little bit deceiving. We can use the various things we know about the concavity of the graph and finding the extrema so that we can get accurate graphs. Let's first look at what the first and second derivatives tell us by looking at them graphically. Our job here is to sketch the function given the graphs of the first and second derivatives. So this blue one is the graph of the first derivative, and we're going to sketch a function going through this point P, because when you have information about the derivatives, you still don't know vertical placement of the graph, but you can definitely get the shape of the graph. So we're first going to consider the first derivative, and what we're interested in looking at this first derivative is when it is 0, and also when it is positive and when it is negative, because the first derivative positive lets us know the function is increasing. The first derivative negative lets us know the function is decreasing. So I'm actually going to divide this graph into intervals based on where the first derivative is 0, because if I look to the left of this dashed line, the first derivative is positive, and therefore I know the function is increasing on this interval. Between these dashed lines, the first derivative's function is negative, so I know the function must decrease between these two dashed lines. And then since the first derivative is positive over here, I know that the function must increase. Now let's look at the second derivative. I'm interested in where it is 0, because this is a possible inflection point, and in fact it is, because on the right side of this, I'm going to go ahead and make a dashed line if it'll show up here along the axis. So we see that on the right side of this that the second derivative is positive, so I'm concave up over here, and on the left side negative, so I'm concave down over here. Now I'm ready to sketch the graph. It begins at point P, and I'm going to sketch it to the right first, and then I'm going to back up. So since I'm sitting here at P, I see that I'm in the area where the function needs to be decreasing, but it also needs to be concave up. So I'm going to make a decreasing function that is concave up. Now as I hit this dashed line, I'm changing the first derivative from negative that made it decrease to positive that made it increase, but it's still concave up. So it would look something like that. Concave up in this entire area, decreasing to this point, and then increasing. Now I'm going to back up and see what I needed to do over here. I need to be concave down for the graph in this whole area. I need to be decreasing as I come along here until this line right here tells me that where I change from increasing to decreasing. So I'm going to make this graph look like this, because this is concave down and decreasing. On this side of this dashed line, it still needs to be concave down, but it needs to be increasing. So it would need to look like this: increasing, concave down, now decreasing, still concave down, now still decreasing but concave up, and now still concave up but increasing. So you get a pretty good idea of what that function looks like by looking at the graphs of its first and second derivatives. I have a link to some that are like this where you can go practice this skill online, because if you can have these graphs of derivatives tell you what the function does, you've got it.